Hi students, coming to the next topic, that is the virtual functions. So virtual function is nothing but runtime polymorphism, or you call it as the dynamic polymorphism. So runtime or dynamic polymorphism. So this is actually, let's see the definition of the virtual polymorphism. Virtual function. A virtual function is a member function. Which is declared within the base class. So within the base class, you have to declare the virtual functions with a virtual keyword. So virtual functions is a member functions which is declared within a base class and is redefined. You can redefine this virtual function by derived class. Okay, that is the definition of the virtual function. Virtual function is a member function which is declared within a base class and is redefined by the derived class. And one more point is, when you refer to derived class, when you refer to a derived class object using a pointer or a reference to base class, don't be confused, let's see it. When you refer to a derived class object, so if you are referring to a derived class object using a pointer or a reference to the base class, you can call a virtual function for that object and execute the derived class function. So when you refer to a derived class object using a pointer or a reference to base class, you can call virtual function for that object and execute the derived class function. Okay, I hope you didn't understand. So I will explain this point, okay, this point by taking the example. So if you see the example, then you will clearly understand what it means. When you refer to a derived class object using a pointer or a reference to a base class, you can call a virtual function for that object and execute the derived class function. Let us see the example. So here I am writing the example for the virtual function. Let's say class A. Here I am declaring the virtual functions as public with virtual keyword virtual void display. Cout content of base class okay, sorry. So class A. Now this is a base class. Now I am writing the derived class, that is class B public A. Public. So here I am not writing the virtual. Only in the base class you have to write the virtual. So public void display cout content of derived class. Derived class will be closed. So here I declare two classes. This is a base class and this is a derived class. So here in the base class I declare the virtual keyword and I am using this function as a virtual function. In the base class I am just using without using the virtual keyword, I am inheriting the properties of the base class. So in the derived class you don't need to declare virtual because it is already declared in the base class, you are inheriting the properties of the base class. So let us see this. Let's see the main function, how I am calling the program. Int main. I am creating a base pointer to the base class. So with the help of the pointers, you can call this derived class. So A star B means base class pointer is created. Base class pointer. So BD. So this is the object of pointer B is a base class A object, and B comma BD is the B is the derived class and D is the object for the derived class. Derived class object. So now I am writing B is equal to ampersand D. It means B is the base class. Okay. So B is the base class. In the base class, I am calling the address of the derived. So whatever the in derived class in that particular location, that data will be moved to the base class. B pointer display. This here, this is a late binding occurs. In this place, the late binding will be occurs. Return 0. So the output of this program is, here only I am calling the B is equal to ampersand D. It is the reference to the base class. So what will be there? The reference of the D is the content of derived. Content of derived class will be print. So here in this example, so instead of printing the content of base class, it only prints the content of derived class. Why it is print the content of derived class? Because B is the base class. Okay, but in the base class, you are storing the address of the derived. So that is the content of this will be stored in the base. So that will be printing here. That is the content of derived class instead of the base class. So I will take one more example. So then you will be clearly understand what. So here in this example, I just only calling the function that is in the derived class. Let us see the example that calls both the functions in the base as well as the derived. So let's see the example for this. Here I am writing example. So let's class A. So class A public. Here I am declaring the function which is a virtual keyword. So that is a base class. I am creating a virtual void show cout. Here I am printing hello base class. So just clearly follow the steps. Here you can understand what is this virtual polymorphism. If you observe the two examples, then you will clearly understand when we are using this polymorphism. Okay, so this is the class A. Now coming to the class B. That is, let's see the class B. So class B public A. Okay, so this is a class B public A public. So here I am not writing the virtual because I already declared it in the base class. So now I am inheriting properties of the base class. Void show. Here I am printing cout hello derived class. Class B is closed. Now I am writing the main program. Let's see the main program. I am writing everything is here. Then you will be understand. Int main. So now I am creating the objects for the class. A is the base class. I created A obj is the object for the base class. And I am creating the object for the derived class. That is a class B. For class B, B obj is the object I created. So now here one more thing I am writing, that is A is pointer, base pointer. So in the previous example also I created a base pointer for the base class. Here also I am creating a base pointer for the base class. With the help of the base pointer you can call the virtual functions. So base pointer I created. Now base pointer is equal to ampersand of AOBJ. What it means? So AOBJ is the object of the base class. So in that particular address location a data will be present. Ampersand AOBJ, this is the address location. In that address location a data will be present that will be moved to the base pointer. So this is the meaning of this. Base pointer is ampersand AOBJ means. So AOBJ is the object of this base class. So in that base class ampersand AOBJ means in that particular object location some data will be there that will be moved to the base pointer. Okay. So first I declared this. So now this base pointer holds the address of this void show. Address of this void show will be stored in the base pointer. Now I am calling this function base pointer show. So whenever I call this function, call base class function. So it calls the base class function and prints the, so what is there in the base pointer? Address of AOBJ. Address of AOBJ object, address of A object will be present in base pointer. So in that function it prints this message. Now again base pointer is assigned to address of BOBJ. So B object is the object of the class B. So in that particular address location, so address of reference of BOBJ means address will be present. So that address will be moved to base pointer. Now the base pointer holds the address of this function. Now it prints the address of that function. So whatever there in this here. Okay. So that will be print, return 0, close the main function. Now what will be the output? The output of this virtual function is first it enters this program because the base pointer is assigned to address of A object. Then what base pointer points to show means it prints the hello base class. Next it prints the hello derived class. So this is the use of this virtual functions. So if you can call with the help of the reference operator, you can call the base class and you can call the functions in the derived class as well. So let us see some rules for this. The rules you have to follow while you are using the virtual functions. In the same way, whatever the rules you have used for operator overloading, for the virtual functions also you have to follow some rules. The rules for virtual functions is virtual function must be member of same class. That you have to be noted, that should be a member of same class. And they cannot be static members. That you have to be remember, because the virtuals is all virtual function is nothing but is a dynamic member, so they cannot be a static. And one more thing is they are accessed by using object pointers. So whatever I said, they can access only by using the object. The virtual functions can be accessed by using only the object pointers. That's why I created for A class the pointer BPTR, like that. For the A class, for the base class, I created the object pointer. They can be accessed by using only object pointers. Next, virtual function can be friend of other function. So it can be a friend of other function. And the next thing, virtual functions in a base class must be defined even though it may not be used. So even though you are not using that definition, whatever you declared in the base class, you have to define. Virtual function in base class must be defined even though it may not be used. So in the previous example, I had just printed it is a derived class. Instead of it is printing the base class, it just printing the derived class even though you written a definition on the base class. So virtual function in a base class must be defined even though it may not be used. So, and the next point is, next rule you have to follow is, we cannot have virtual constructors. So virtual constructors you don't have, but we have virtual destructors. So you can have the virtual you can have the virtual destructors, but we don't have the virtual constructors. So these are the rules you have to be followed. So this runtime polymorphism is achieved only when a virtual function is accessed through a pointer to the base class. Only pointer to the base class is there, then only you can access the virtual functions, and it can be achieved the runtime polymorphism. That's it. Thank you.